Hi, everyone, and welcome to the next part of solving the hospital patient data set. As we have seen till now, we have worked with, SweetWiz and seen the report, right, where we know pretty much our data. And now we're going to look at collect. Now, in this project, there's no extra data, and this data is stored in Google Drive. We know that, so there is not much that we have to do at the collect stage here. If this was data where we needed to connect to a server or etc., we would have had to do more work. Okay, if we can think of it like that. Okay, so then we go to the organize step. In the organize step, there are a few things we will look at. We'll look at missing values, outliers, dummy variables, and derived variables. We've already identified that the tenure in hospital is missing and it can be calculated from the discharge date minus the date of admission. Right? So, small formatting issues I can see here. Okay. Okay. So we can calculate the derived variable from discharge date minus the date of admission. Let's therefore get on with dealing with missing values. The first thing we want to do is to identify the columns with missing values and then do their count exactly how much is missing. And if now this is something which I learned a bit late in life because it's always better to put in this print statement which tells us if there are missing values found or not found. It's so much easier to conclude, rather than going through the output and trying to see it. So what I've done is I've written missing values is, in Python, is null will give us the missing values. So from the data frame, we should sum up the is null. And there is another set called missing values, which I'm creating, where the missing value is greater than 0. So this is to filter out only the columns with missing values in it. Now, if the missing value is empty, it is to print no missing values found. So there are no columns with missing values. Else print columns with missing values and their count, which is what? This, the second row, right? So let's run this code and see. So when we run this code, what do we find? It's taking some time to process. But, I'm sure this will give you a good idea of. Now, this code has not run from the beginning. So I will just do a run all. So you will now see that it's actually asking me to connect back to the Google Drive. That Drive connection from Google Colab has gone. And it will rerun all the codes we did in session 1. And then it will run this particular code too. So here you have this option in runtime. We also have the option to interrupt an execution and restart the session. But I think you already know this, or you can see the video that I have made on working on Google Colab for an easier access to it. So here you go. It's already run the earlier statements and we get an outcome which says no missing values found. Okay. Now, the next thing, so missing value is sorted. Now, the next thing that we want to do is to find out the outliers. Now, in my experience, only Y variable, which is numeric, is the billing amount, and we should check there for the outliers. Also, the age can be converted to numeric and check for outliers. Since the data set is large, and it certainly is greater than 30 rows of data, which is the mandate as per central limit theorem to look at normal distributions, I will use the Z-score and normal distribution to find out the outliers. Again, as a rule of thumb, I'm going to look at 3 standard deviations from the mean, plus and minus 3 standard deviation from the mean to define what is normal within scope and what is out of scope. The other method we could have used is the interquartile range, but I personally like the normal distribution method better. I feel more confident about it. So here, what do? I actually import NumPy. Now, what is NumPy? It's a fundamental library in Python, which is used for numerical and scientific computing. Hence, it is important because now we are entering the realm of statistical computing. So we've already got pandas, we already got SweetWiz, and now we've got importing NumPy, and we are importing from Z-score, because I've already mentioned the fact that we are looking at calculating the Z-score to do the outlier. Now, which package am I using here? So I'm doing SkyPy and the statistics package under it. Okay. Now, one thing which you will always know is that you can always look at the code and understand this. So the module is SkyPy, it's telling you, and the statistics module within SkyPy, it's going to be something. Now, again, here, there are people who called it Skippy. Okay. So it is up to you. I just find it easier to call it SkyPy. If you need to look at NumPy and SkyPy together, you can think of NumPy as the engine and SkyPy as the toolbox. And together, they help in scientific computing, advanced mathematics, statistics, and data analysis. Now, though we already have seen that age is a numeric over here, but I just want to be confident that I'm not making a mistake, that I'm not missing out on anything. So what I want to do is I would just, again, as a point of demonstration, I would just look at DF age and say two numeric. Okay. And error scores to ensure that all of the values within age are numeric before we run the next set of codes. Now, what do we want to do? We want to actually create the Z score and put a threshold of 3, right? The Z score plus minus 3 standard deviation. So what is the Z score? It's easy for me to understand Z score by thinking about it as the standard deviation of that particular point from the mean, right? It is the standard deviation of that particular point from the mean. Hence, it can be, if it is 0.5 or it is less than 1 standard deviation away from the mean. If it is 1.5, it is less than 2 standard deviation, but greater than 1 standard deviation. So it's like the standard deviation of that particular point. So the function to calculate the threshold and detect outliers would be something like this. First, we define the function, detect outlier Z score, and then we define the data column and the threshold, which we have put as 3. Right. So when we are looking at standard deviation, you know that it is always from the mean. So the first thing we want to do is actually calculate the mean of the column. Yeah, here we are talking about 2 columns. So we're writing a generic code which will then run over both the columns. Okay, first it will run on one column, the next it'll run. So it'll run on billing amount and then it'll run on age. Mean is going to be the data column, and then calculate the mean function. Standard deviation is the data column and calculate the standard deviation. Then we will calculate the thresholds. What are the thresholds? It is mean minus threshold, which is 3. We have said, right, Z score less than greater than 3. 3 into standard deviation. Upper threshold is mean plus 3 into standard deviation. We have defined threshold over here just to, for, so that there is no confusion. You could have defined it as 2 also, if that gives you more confidence, but general rule of thumb is 3. Then what we do is we actually print the thresholds, okay, for each of the columns, just so that we know what is the, the band in which the system is seeking to operate. And then we compute the Z scores. And what we write here is NaN policy is equal to omit, which is if there is a missing value, we know there is no missing value. But just as a precaution, if there is a missing value of any kind, then we want to omit this, right? So this is what we are saying. So let's run it. Okay. Then what we want to do is identify the rows where the absolute Z score is greater than the threshold, and return the data of where it is greater than the threshold and less than the the upper limit, right? So we want to know the data which is in between the limits, right? What do we want to remove? We want to remove the data which is greater than the threshold and less than the threshold, the two tails, right? We want to remove that data. And what do we want to retain? We want to do mean plus 3 standard deviation, mean minus 3 standard. We want to keep the middle part of the curve. So if this is the normal distribution curve, the mean is in between, and we want to keep the middle part, and we want to remove the outliers, the furthest parts, the tails on both the side, if that so exists. So let's look at how this works. Um, After we find it out, so we do the outlier for billing and the outliers for age, right? We actually take out the Z scores, and then we remove the outliers. So even if if it's an outlier in any one of them, right, you have to remove it. So you're going to do a union of all the outliers, right? Any row with any outlier has to be removed, right? Because it's on a row level. Okay. So we create a new data frame after dropping these outliers for both these columns. So let's look at what remains. What we want to keep is a data frame cleaned. Okay. So let's just run it. Here you go. The lower -3 standard deviation is -16685. We know that actually, though the normal distribution can be from minus to plus infinity, we know that, you can't have money which is less than 0. And in fact, we know in this data, we have money starting from 1,000. Okay. So, obviously, we don't have any outliers on the left side. When you look at the upper standard deviation, also it is at 67,718.68, which is much larger than that 50K limit that we have seen, right? When we did the info. No, when we're doing the minimum and maximum of the values that we have over there using the sweet whiz, right? I forgot about that. So threshold for age, again, you see it is -7.31, which is below 0. We know that all the ages were starting above 18, and the upper is 110. And we know that there was no age above 85. Yes, you can go back to the sweet whiz report and check it out if you don't remember it. So there was no data which got removed, in the outlier treatment. Okay. So this is great. Now let's go to the derived variables. Here, what we wanted to do was we wanted to create a tenure in the hospital. What is this? This is the discharge date minus the date of admission. And to do this, what we really need is that the dates should all be in date time. So just like we had done age to numeric, here we do date to date time. Okay, for both the dates. Here you can see. Then we calculate the tenure, which is we make a new field, tenure in hospital. So df dot tenure in hospital is equal to df discharge date minus df date of allocation. And the way this output should come, it should come in days. So we are specifying it. We don't want something which we cannot interpret. Now let's see the first few rows where how does this whole thing look? And here you go. You can see that the tenure has come out in days, just the way we wanted it, right? And then we're going to look at dummy variables. So the first thing that we can do is that we can look at columns which have only up to 10 categories, because if there is very granular columns like name, if you remember, name of the patient or name of the doctor, there were just so many options, right? There were only a few patients. There were some 9,900 odd, separate names of patients. So obviously, those would be things we don't want, right? So what we do is we'd like to look at, only keeping those fields which not more than greater than 10 categories within them. Okay. And for those fields, we want to create the dummy variables if they are not numeric fields already. So first we will identify the non-numeric columns. So I'm creating categoric columns, which is a data frame which should include object columns only. Okay. Then the columns with 10 or more unique values. So these are high cardinality columns which have many unique values. They have greater than 10 unique values. And then what we want to do is to drop those with more than 10 unique values, right? So the ones with multiple repetitions, so many that it will not really help in the model building. So we create one new data frame called DF filter, which is what? It is the data frame, the original DF minus the high cardinality columns. Okay, so we've already seen that the data frame, even prior to this, okay, where we were trying to remove missing values and outliers, no rows got deleted. So we can as well go back to an original data frame, which is DF, and drop these high cardinality columns and look at it. So what we will really see is, I will just. So the columns with 10 or more unique categories like name, doctor, and hospital, these were dropped. Okay. These were dropped. And let me just add another code base here, or actually just above this. Insert a code cell. And let's look at this. So now what we want to do is we want to do the dummy creation. So what are we saying? That we want to look at all the remaining sorry, I'm just editing the code because earlier I was looking at 6 categories. I wanted to change it to 10. So what we want to do is we want to run the dummy variables for those columns which have up to 10 categories. So what does it? These are low cardinality columns, right? So these are columns in the DF filtered, which are object. Okay. And And what we want to do is we want to create the dummy variables. Okay. And when we create the dummy variables, we want to drop the first. That means the original column, which was there, on the basis of which the dummy variables are being formed, they need to be dropped, right? Because any further analysis can only happen on numeric columns, and dummy variables will create 0, 1 columns for the categories within it, right? So if it is male and female, the dummy variable would be gender is equal to male, and it would have 0 and 1. If the gender is equal to male is 0, that's the same as saying gender is equal to female, right? So that's what we'll do. We will actually look at this data. And what we find is that you have, of course, all the numeric and date time columns, because date time is, it is treated like numeric. And here you have tenure in the hospital, gender male, as I told you. Always do remember that when they create the dummy variable, it's always n minus 1. So if there are two categories, male and female, there'll be only one column, because gender male 0 is the same as saying gender female. Okay. So here you have the blood types, right? You have the medical conditions, the insurance providers. All of this is done. And now you have a data set which has numbers, all of these are, you can see over here, they are integers, right? Date, time, or Boolean, which is yes and no, right? If you want to see the head of this, you can. It will give you an idea of how the data frame is looking. Mhm. We will replace the false and true with zeros and ones soon after the visualization, right? So we'll take a look at the visualization once and then decide to do true and false. Now, we'll convert true and false into zeros and ones. Okay. Now, why are we talking about this? Because see, now the next step we've done define, we've done collect, organize, and the next step is visualize. Now, in this project, visualization is not the scope of the project, right? It is not the aim of the project. It is not that they have said that make us a report or a dashboard and stop at that. So the visualization, we will run the visualization here, but it will be run only from the point of view of us understanding the data better, of us feeling more confident about the process. So the first thing to note is that there are some specialized libraries that you need to have in your system if you want to run visualization. So you have matplotlib and you have Seaborn as two big libraries that you want to use. Now there you can get, so you would know this, each package in Python has its own web page. So you can go and look up the web page to learn how to use each of the packages. But here one of the things to understand is SNS, which is Seaborn, has certain styles, that you can look at, and whichever one you use, whichever one you feel comfortable, you can use. Now here I set it to white grid and I want to draw a few of the statistical plots, graphs and charts, like an histogram for age, okay, with 20 bins. Okay, here you will notice the flow is simple. Plot the figure size is 6 and comma 4. This is the size of the graph. You want a hist plot. Okay, so what type of a plot it is? Down you will see box plot. Okay, so it's very easy. Figure out what type of plot you want. Sorry, excuse me, please. And go ahead and just fill it up. Okay. So plot title is age distribution. X label is called age, Y label is called count, and you want it to show you the plot. Okay. Pretty simple, pretty straightforward, and pretty repetitive, you will see. This is a box plot. Okay. This one is a count plot, which is the count of conditions. This one is again a histogram plot. So just to show you, you can go here to seaborn.pydata.org and they actually have a tutorial where you can get the codes and insights to draw so many different types of graphs. If you're wondering, that this part, the visualization seems a bit difficult, I will suggest please practice a bit over here. You can see they have many, many types of options, including statistical relationships, which is what we were seeing. We can also look at distributions of data and categorical data and how to distribute that, right? And observe and create graphs around that. So just go ahead and look it up here. Do not feel that, oh my God, how do we do it, right? So, and the last one is actually a correlation heat map where we are looking at age, billing amount, and tenure in hospital to see that is there a correlation amongst these three items. So let me just run a lot of these graphs and charts, all of them together. And here you go. This is the tenure in the hospital distribution. Which you can see. Here is the correlation heat map. Okay. Of course, the other distributions are, within this. Okay. This is the count of patients by different medical conditions. Right. Now with this, I will come to a stop of this session And I look forward to starting the analytics and insight session and sharing it with you really soon. If you have enjoyed the video, please do subscribe to the channel, and I look forward to bringing you more content like this. Bye.